Everybody, can you see my screen?
Yes.
Yeah. You see the first slide is final exam information. As you can see, so your final exam will be held on May 7th. And just keep in mind the time is different, not the class time. It is from 10:30 a.m. to 12:30 p.m. I mean, this is, university allocated time. So as you can see, the duration is 2 hours, but I will make the exam available at 10 a.m. So you can see on the eCoursera that final exam script is available around 10. So right after that, you can download and start answering. And finally, you have to upload the script on Dropbox at 1 p.m. So in fact, you are getting about 3 hours, but I'll be asking you only 7 questions, as you know. So I think that time is enough for you. And the question pattern will be the same as the midterm exam, like exam 1, 2, 3. It is the same pattern. And for the syllabus, you have to look all class lectures, starting from 1 through today. Today is class 22. You have to look homeworks, class quizzes, numerical problems, and all the short questions, including today, we will be discussing few questions. Those will be the syllabus. Um, Still, I am checking and grading your exam 3. So how was your exam 3? Did you all do well?
I felt like I did pretty well.
Okay, great. So hopefully in a day or two, I will notify you. Once I will be ready, then I will notify you so you can see your grade. And also I will make the answers to the questions of the exam 3 available on eCoursera. Because today is the last class, so we don't have chance to discuss those answers, but I will write down the answers and then I will make those available. So then you can compare your.
Dr. Ali, did you say the final was, Dr. Ali?
Yes, I can help.
Did you say the final was 2 hours or 3 hours long?
3 hours. I mean, here I am showing you the official time.
Okay.
This is university allocated time.
Okay. I was just making sure.
No, but I will. You can see the final exam paper on eCoursera at 10 a.m. So this means right after that you can start, and finally you have to upload the scanned copy at 1 p.m. So in that sense, total 3 hours.
1:30 p.m. or 1 p.m.?
Just 1 p.m.
Okay.
Yeah, but you see, as I mentioned, I will be asking only 7 questions. So I believe about 1 hour and a half is enough to answer those 7 questions, assuming that you know the answer of all questions. And then so about 30 minutes for scanning and uploading. So I believe that time frame will be fine. But it's comprehensive, so it's you have to start looking from the first class to until today's class. But the question pattern is the same, so you are fully fine. Okay. And then the last one, please don't forget to complete your SAT. I think there is a deadline by the university. I don't know. Probably tomorrow is the last class. Either tomorrow or maybe one more day is the last date. So please complete that SAT. Okay.
Excuse me, sir.
Yes.
Sir, this project report we need to upload in a Word format or a PDF format?
I would prefer in Word format.
Yeah.
I would prefer Word format. Oh, so those who have submitted already, what was the format? Did you submit in Word file or PDF file?
Yeah, we are planning to do it in Word file.
Okay, so
I'll be doing by today.
Yeah. Due date is today,
After the class.
11:30. Yeah.
Yes, sir.
Okay. So excuse me, so those who have already uploaded by PDF file, can you please just send me through email your Word file of the submitted file? I noticed, I think 3-4 of you have already uploaded, but if that is the PDF file, please just email me your Word file. Okay, so moving forward. Today we will be discussing, a new topic, cybersecurity issues and solutions for photovoltaic, that is PV system connected to power distribution grid. I mean, almost we are at the end of the syllabus and of this chapter. So this is a specific case. What's the cybersecurity issue? How cybersecurity happens on solar system, and what's the solution? So we'll be looking at. So everybody see this example. Here is a PV system connected to power distribution grid. So as you can see, there is a solar farm, photovoltaic farm. And at the bottom, you can see battery energy storage, which are connected here. And in the PV system, there is MPPT control, that is maximum power point tracker. And then this is the DC to DC boost converter. This is DC link. And here is the smart inverter, which are feeding to that main distribution grid to which customers or the loads are connected. Now on top, as you can see, I have written photovoltaic park SCADA system. So here is the SCADA. And on the right side, as you can see, I'm assuming that there are cyber hacker or cyber attacker shown in red colored. They are entering, they are injecting bad signal. And how they are affecting, you can see that there are two types of dotted lines. These magenta colored dotted lines are for the bidirectional communication. For example, SCADA is sending signal to smart inverter is sending signal to SCADA, bidirectional communication. Similarly, SCADA has communication with the smart load, SCADA has communication with energy storage, and the PV system. The red lines, those are the cyber attack line. So cyber attacker is injecting bad signal to SCADA, and through SCADA, that bad signal or attack is going into the smart inverter. One example, other example you see from SCADA, it is going to DC converter of energy storage system. And also you see the other line, attacker is sending bad signal to the duty cycle. That duty cycle is being produced by MPPT control, and it is the input to the boost converter. So this means I am showing the exact three examples that attacker is hampering the smart inverter, attacker is interfering the DC to DC converter so that the energy storage doesn't operate properly, and also the duty cycle is being changed so that the DC to DC boost converter gets wrong information signal. Accordingly, it affects the power grid performance. So this is the scenario. Now, we already discussed in previous classes that cyber attack has negative impact. It has adverse impact. So today we will be looking some example how the cyber attackers impact inverter and then duty cycle and battery energy storage, how they degrade the performance. And also we will be looking how we can detect that, how we can understand that there is cyber attack, and what is the solution. We want to put some sort of mitigation controller. Then everybody see on the SCADA, I have put some mitigation controller on the SCADA. You can see this one, this green colored controller for cyber attack mitigation. And as you can see, the green control V reference, here control P reference, control duty cycle. This means, as you can see, that when cyber attacker is changing the signal, smart inverter or DC to DC converter or the duty cycle, those are the red color. But with the help of detection technique, we will be detecting that there is cyber attack. They are changing the smart inverter, duty cycle, or energy storage. After detection, we will take that information on this controller. I mean, later I will show you the control structure, and that will control the V reference. So this means this attacker or changing the V reference signal for the smart inverter. So we will correct it, we will modify it. That is the meaning of this signal. And then same thing, we are assuming that attacker changed the P reference value by changing the duty cycle here. So we are correcting that signal. So control P reference, control duty cycle. So therefore these green colored portions, blocks are for the mitigation controller. So therefore, that is the thing today we will be looking. When there is no controller, what is the impact on the power grid? And second thing, how we can detect, how we can understand that there has been attack. And then finally, how we can mitigate that adverse impact. This is our main topic. So far, everybody understands this diagram. Okay, so moving forward, as you can see, here is that control algorithm or the detection mechanism. As you can see, we are starting, here is that flow diagram, del VDSA. This means that, once again, we are assuming that when attacker is interfering with duty cycle or the DC to DC converter, so there is some sort of change on the DC line, meaning that the DC voltage will be changed. That's why. So what I am calculating del VDC, change in DC voltage, which is the reference DC voltage in per unit, and then minus DC voltage measured value. What is the real time value? That is I am taking, and I am comparing with reference value. Typically, under balanced condition, when there is no fault or no disturbance, then there should not be any change in reference voltage. So this means del VDC should be 0. So now see the flow. If del VDC is 0, then, sorry, whether del VDC is 0 or not. If it is yes, then there is no issue, continuously monitoring the system. On the other hand, if del VDC is not 0, meaning that there is some value, so that is the no. So this means it is cyber attack or other disturbance. Here is one important thing. As I said you that due to cyber attack, there will be change on DC voltage or the DC signal, but it might happen that there has not been any cyber attack. There has been some sort of load change, for example, or due to other reasons, open circuit or some other short circuit somewhere in the connected network, still the DC voltage will change. So now, because here I am comparing the DC voltage, how do you understand that this DC voltage change is due to cyber attack or due to other disturbances? So that's the first question. So that's why you see I have written first distinguish cyber attack from other disturbances by some machine learning based detection method. So there are some intelligent artificial intelligence based technique which is called machine learning based detection technique. They can distinguish the disturbances, whether it is cyber attack or other type of disturbances. So if it is For example, it is not cyber attack, it is other disturbances that is confirmed, then activate the associated suitable controller. This means that today we are not discussing about these things. We are assuming that in any power grid, already there are sophisticated or appropriate controller installed, which will tackle or handle those other disturbances, like some fault, short circuit, some load change. But today we are looking the cyber attack. So if that is not other disturbances, if it is cyber attack confirmed, then activate the attack mitigation controller for that energy storage controller or duty cycle or inverter. This means that again going back this up. So once you are confirmed that this is cyber attack, only then you activate these controllers. If the attack is here, then activate this controller. If the attack is here, activate this controller. If the attack is on the duty cycle, then activate this controller and accordingly adjust or correct or modify the DP reference or V reference. That is the meaning. So, and then, okay, you activated those controllers and then check the controller performance. So your goal is, because you are comparing the DC voltage, whether difference is 0 or there is some value. If it is 0, then fine, yes, then deactivate the controller. You don't need to connect it. Because if you long time keep it open, then again cyber attacker, cyber attack may understand, may know the presence of that controller, and they may try to destroy that controller, your mitigation controller. So once you get the desired value of the voltage, then deactivate the controller and the processor. And if it is no, still there is some value. This means still controller needs to adjust. So that keep going, keep going. This is the loop. Everybody understands what we are discussing?
Yes, doctor.
Okay, great. Okay, so then regarding that detection method, there are lots of methods. In the class, those who have presented papers about cybersecurity issues and solution. So you already mentioned some of the methods. So in the next slide, just an example of cyber attack detection method. This is called support vector method, SVM, support vector machine-based attack detection method. So basically, it requires some history of data, some attack data, some information of those voltage, power, how it goes affected, this history of data, and then make some sort of training, like SVM data formatting, define SVM parameter. There are some cost functions, some equation called kernel function, regularization, and that is the training. And once the data is trained, then there is cross validation process, and then check it can properly classify or not. If there is any misclassification or not. If there is misclassification, yes, then again update the parameter. And so this means this is the kind of the training. So once you train the system and it can properly classify, then apply some real data. So up to here, these all are the like history of data, previous data. But here, once the system is trained, it can properly classify. This means you got a trained model of that structure, then test by applying some real-time data. And then once you apply, and then say final classification, attack or no attack. This means the other type of disturbance. So this is just one example how the cyber attack detection happens. There are several other methods. I mean, these days, artificial intelligence and machine learning based detection technique are very popular. Now, moving forward, we know that definitely cyber attack will have negative impact on the system. But what is the mitigation strategy? So already I explained you how it will mitigate the negative impact. So here are again one example. So as you can see, I tested some system using simple nonlinear controller and proportional integral, which is called PI type of controller. So everybody see, I have written down two equations, equation 1 and equation 2. This is nonlinear and this is on proportional integral controller. So as I told you that in my control algorithm, I am using the difference in voltage. So therefore you see, for example, in PI controller, for example, the cyber hacker changed the duty cycle. They hampered the duty cycle. So how can I modify it? How can I fix it? So this is my input. And then this portion Kp plus 1 over Ski, this is the proportional integral gain structure. This is that block. So this means I'm multiplying the input and that PI controller with the parameter settings of Kp and Ki. It will produce a modified value of D. Now to get the appropriate value or the required value, you need some sort of tuning of Kp and Ki. Similarly, in this case, this is nonlinear controller. You see, on minus K2, this K2 and K1, these are some sort of parameters that you need to tune. Exponential e to the power minus then absolute value of del VDC multiplied by Q. I mean, there might be other structure, and there might be other form of equation. This is not the only one, or may not necessarily it will be PI controller. It can be fuzzy logic controller. It can be other sophisticated controller. These are just some sort of example that how we can build, how we can develop attack mitigation controller. So this means you assume that these controllers are here. Now see inside the picture, this is one example. In the example, we are showing that battery energy storage. So you know that cyber attacker entered into the SCADA and they changed the P reference value for the battery energy storage. Now you see in between, I have placed that cyber attack mitigation controller. So now think that there is no mitigation controller. So if there would be no mitigation controller, then what would happen? Cyber attacker entered through SCADA. It changed the reference power for energy storage, and that reference power directly worked for the battery energy storage controller. This means in that case, battery energy storage will degrade the performance. It will not properly charge and discharge. Or when it is time charge, it will discharge, or when it is time for discharge, it will charge, or it will not do anything, neither charge nor discharge. So ultimately, the negative impact will go on the power grid. But what I am doing, okay, so cyber attacker entered through SCADA, it changed that P reference, but I put some sort of attack mitigation controller. In that case, I mean, although in the example, in equation 1 and 2, I showed duty cycle case, but for this case, P reference, you can put here instead of D, P reference. Instead of D, it is P reference. That is the meaning. So this means your cyber attack mitigation controller corrected that P reference. This P reference here, it got hampered. It got attacked. But in between the actual BS controller, I put the cyber attack mitigation controller. So that mitigation controller in this format, either this format or any other control format, that will modify or adjust the value of the P reference. Accordingly, the correct signal or nearby correct signal will go to the battery energy storage system. Same thing is true for inverter system or any smart load system or DC to DC converter case. For any case, you can use similar type of controller. Now, let's see some example how that controller works. So here everybody see, I have shown some preliminary results, effectiveness of attack mitigation controller. Now you see this one, in this case, I have assumed left side response is for duty cycle, right side response is for DC link voltage. Now we have assumed that cyber attacker attacked the duty cycle of the DC to DC converter at 0.5 seconds. So everybody see, initially the duty cycle value was 0.5. And what did the attacker do? Attacker changed the value, it dropped down to 0. And that 0 value, you see the red signal, it continued until 10 seconds. So this means this is the attack. So in the response, you see there are 3 legends: DDoS attack with no controller, DDoS mitigation with PI controller, and mitigation with nonlinear controller. I am showing the effectiveness of the previously mentioned 2 controllers. So now see that green color response is for the nonlinear controller. And then this dotted blue color response is with PI controller. So as you can see, once the cyber attacker changed the duty cycle, immediately it was detected and those 2 mitigation controller worked, and then the duty cycle value was brought back. Although there is some spike or little oscillation here, but afterwards, like 7 seconds, 8 seconds, it properly matches with the 0.5. Now, because of the change of the duty cycle from 0.5 to 0 value, what happened? DC link voltage, everybody see, initially it was 400 volt. And then the attacker changed it to some lower value, probably 250 volt. And continuously it is 250 volt. But then see that impact of PI controller or nonlinear controller, those brought back to the original condition. Now, everybody see that although there is some sort of spike here, some sort of hiccup or oscillation here, but like from 2 seconds or 3 seconds, you can say the voltage properly returned back to the original value or the steady state value. So in this case, you see, if you see caption, I mentioned single DDoS attack on duty cycle and the mitigation effect on duty cycle and DC link. This is single attack. This means attacker just attacked only once and it continued 10 seconds. But attack can be repetitive. For example, everybody see this example, it is called repetitive DDoS attack. So it is the same thing, repetitive DDoS attack on duty cycle and then impact on duty cycle and DC link voltage. So what happened, what intruder is doing here? Intruder is changing the duty cycle value from 0.5 point to 0 at 0.5 second. And it continued until 1.5. And then again intruder, and then your controller fixed it. Those PI controller or nonlinear controller worked. The dotted green signal. Your duty cycle returned back, and then it looks it's properly fine. Then again there is another attack at 3.5 seconds. Again intruder changed the value. And again your controller worked. And then again at 6.5 seconds, another attack. So it is called the like multiple or repetitive attack. And because there are many attacks, you can see that although controller is working, but there is little oscillation. But still that is fine. So here you can see on the DC link voltage profile, initially voltage 400, but because of the change of duty cycle, there is corresponding change in voltage. So voltage change, but controller return back. Again, there is another attack here, but the controller changed, but controller affected. So this means you see, so in this case, because this is voltage response, there is huge, that is spike or the oscillation initially, but that is okay. Because after a little while, the voltage is coming back to the original 400 volt. So in that way, you can put the mitigation controller. Uh, everybody, could you follow me so far?
Yes,
sir.
yes.
Okay, great. Okay, so in that way, so we'll move forward. Um, Here I will show you just few standard terminology with regard to cybersecurity issues like vulnerability, threats, then the control. These are kind of common terminology, like many of you have studied in your paper and you have used these terms. So what is the vulnerability? It's basically a weakness or bug in the computer system that might be exploited to cause loss or harm. So from general sense, you know the meaning. But you have to keep in mind that a vulnerability does not necessarily mean that attack will occur. Rather, it means that an attack can occur, or there is the high chance or high opportunity for an attack to be present. That is called the vulnerability. Vulnerability means kind of there is some sort of weakness or bug. It looks, for example, in real life, you have noticed that time to time your computer screen is getting little bit blue and then immediately it is coming back. Or a long time you have not updated some sort of software. So it looks like suddenly there is some change. Your computer is not crashed, your data is not hacked, but your system is vulnerable. That is the meaning of the vulnerability. That's why it says in computer language term, it is the weakness or some sort of bug in the computer system that might cause some loss or harm of your system. This means attack might occur, not necessarily will occur, but might occur. So you have to be careful. Now, what does the terminology threats mean? Threat is a set of circumstances that have the potential to cause loss or the harm. And a threat exploits vulnerabilities of the assets in computing system. Now, you have a lot of vulnerabilities in your system. Your computer is not crashed, your data is not lost or get harmed. But if every day something happens, this means it's a huge threat. I'm sorry. That is the meaning of the threat. So threat is the set of circumstances that has the potential to cause loss or the harm. And then control, just now we discussed, control is the protective measure. It's an action or a device, control device, or a procedure or technique that reduces vulnerability. And then a threat is blocked by control of vulnerability. So therefore, just you will be looking these three terminology: vulnerability, threats, and control. Now, moving forward, we are almost end of the class. There is one terminology which is called Advanced Metering Infrastructure, which is called AMI. So this is basically with regard to that metering system at our home. So here you can see that left side conventional metering system, and then right side, as you can see in the sealed box, only we can see the display, and that is the smart metering system. Now, so why is it needed, or what is the evolution from the conventional meter to the smart meter? So I think in the next slide, I have seen the evolution of electric meters and why this is important. You know that 90% power problems have their root cause in distribution meter. So you all know that as a customer, we all are connected to distribution power grid. For example, in terms of Memphis, we all are connected to MLJW system. So MLJW is the distributor, or it's a distribution network. And how we are connected to the distribution network with the help of smart metering. That is the meaning I have written that 90% power problems have their roots in distribution network, because metering side of distribution system has become the focal point of discussion. That's why we are looking at this evolution. So here, as you can see on the y-axis functionality, on the x-axis return on investments, this means performance, you can say initially electromechanical meters. And then the improved version, it is called AMR, on-way automated meter. It is not two-way. Then the evolution of AMI, advanced metering infrastructure, or two-way automated metering infrastructure. And that two-way automated metering device is connected to the smart grid. And what is that smart grid? It's an interconnected network of microgrids with distributed control. So this is the evolution process. So at the bottom, you see, I have written like AMR. It can let utility read consumption records and it can get alarms and status, but it's still it's one-way communication. I mean, this one, this purple one. And it cannot meet demand side management requirement because it can provide only one-way communication. But AMI, this one, this green colored one, it provides two-way communication because it can provide or it can get instantaneous information from customer. So this means that both the distributor, both the utility and customers will be benefited. Now, once again, like in summary form, why do we need smart meters? Because we need smart meters because it will let home users actively manage their energy usage. Thus, it can control utility cost. I mean, before in previous classes, we discussed the demand response. We discussed these points, again, kind of repetitive. And also, smart meters can let industries better planning operation hours according to time of use price. What is the price now? What is the price next 2 hours? What is the price 5 hours? Based on that, they can properly schedule their loads so the industry have much better regulation and operation planning in their system. And then overall, the smart meters can enhance energy transmission management and also increase system resilience to system failures or cyber attacks. Because once there is any cyber attacks or system failure, there will be some sort of impact on the system. So the smart meter signals, the collected at the control center of the distribution system, they can take precautionary measure, both their distribution and transmission system. This means that they can improve, they can augment their transmission capability. They can properly manage their transmission system, and in other words, they can enhance the system resilience to any types of failures or the cyber attacks. That's why smart meters are important, and we have to look the advanced metering infrastructure. Now, why today I have brought this topic in front of you? Because there can be cyber security issue in smart meters. So what is that cyber security issue? How does that cyber attack may happen in smart meters? So you can see what hacker can do. They can alter or change the reading. So this means I have written altered readings from the meter or the device can lead to incorrect billing and false power usage approximation. Now, someone hacked your meter and someone changed the data, but the MLGW will know that, okay, you are consuming this amount of, but that is the false information. That is not the correct information. But you will be getting incorrect billing, maybe very high bill. Altering smart meters can provide attackers with monetary gains. They might gain some money. It is important that smart meter readings are correct and not modified. But what is happening, because we want to achieve the benefit of modern power grid, the smart power grid or smart microgrid, so we have to add much more renewable energy sources into the conventional system. But adding more renewable sources meaning you are adding more third party. So the power system becomes more vulnerable to cyber attack. So this means that clearly cybersecurity issue may happen in the smart metering system. Okay, so I think we discussed all the main points, and time is pretty short, but just I have set up 3 questions, and even I have written down the answers for you. So it will not take time. For example, the first question is, mention some critical infrastructures that should be protected from cyber attacks. What are the critical infrastructure? So I have written down the answers like power grid. This means that the modern grid, smart grid, any power grid are critical infrastructure. Those are the cyber physical system. So it is highly likely that there will be some cyber attack or cyber hacking. So we have to protect that. Any hospital, university, bank, any government office, post office, police station, fire station, any supermarket or any other premises. These all are called the critical infrastructure. See the next question. So is there any possibility that a supercapacitor or coil energy storage system may face any cyber attacks? So what do you think that can supercapacitor or coil energy storage or hybrid energy storage or any type of energy storage may have cyber attacks? So I have said in answer, yes, there is a possibility, because you know that whatever it is, supercapacitor or superconducting magnetic energy storage, or today Omar's group was discussing the hybrid energy storage, whatever the storage, you need some sort of measurement in your control system. You need some real-time measurement. So in most cases, it is the line power measurement. So during the line power measurement and necessary signal transmission to the energy storage controller, that data can be hacked or attacked. So the answer is yes. And then just now we discussed, can the smart meters data be hacked? Yes. The smart meter data can be hacked during sending information on energy price from the utility to the customers, and also during sending customers' energy usage data to the utility. Because these smart meters can provide bidirectional communication and it is online, so highly likely that there will be cyber attack or the cyber hack. So these will be like the sample questions for today's discussion. Do you have any questions and comments?
Dr. Ali, I missed it earlier. The reports submissions are not set up as a group submission. So do you want us each to submit a copy, or just want one apiece? Like one per group?
Just one per group.
Okay.
I mean, you have to prepare. I mean, all you have to take part. For example, in your group, you have 3. So everybody should participate in preparing the report. But anyone from the group, just you upload on Dropbox. So because I know who is in your group, so everybody will be equally graded.
Okay. I just wanted to double check because I know that there's a way to do a group submission, but it wasn't set up the particular way. I just wanted to double check.
Oh, okay. Oh, so probably I clicked the submission, like per person submission or something. Yeah. I understand. So please just
Thank you, sir.
just you submit, or just one of your group mates submit. So I will understand. No problem.
Okay.
Okay. Thank you.
Thank you.
Okay. Thanks. So everybody, you know that I think your project report submission due date is I think 11:30 p.m. Tonight. So please everybody submit by that timeline. With that, if you don't have any questions, so thank you all for registering this class and participating in this class. And see you on the final exam on May 7th. And those who have attended late in today's class, on the first slide, already there is final exam information. And again, I will send you a reminder email 2 or 3 days before. So therefore, thanks everybody. And then how many will you graduate by this semester?
I'll be graduating.
Oh, Joshua Foster. Okay. And I think, how
I
about,
would as well.
okay, okay. And then,
I'm graduating.
oh, okay. Oh, Victoria. Yeah. Okay. So those who will be graduating, like, advance congratulations, and wish you all the best in your future career and in your job plan. And just if in case anybody needs any type of recommendation letters, don't hesitate to contact me. I'll be glad to support your application. I mean, I can easily provide you the job recommendation for you in case anybody requires. Okay, so with that, I'd like to conclude here. So does anybody have any questions, comments?
Thank you, doctor, for this wonderful course.
Okay, so thank you. Thank you.
Thank you.
Thank you,
Okay,
sir.
thank you. So I stopped.
Yes, sir. Thank you.
Okay.
Thank you, sir.
Okay.
Thank you.
Okay, so thanks everybody. Have a good.
Thank you.
Thanks.